Hello everyone, and thank you all for being here today. My name is Aaron Meta-Hill from the Teledyne Scientific Camera Division, and today representing Teledyne Photometrics. Just to let you all know, due to the multiple speakers we have today and the fact we are hosting several sessions, this webinar is pre-recorded. However, we welcome any questions in the chat, which will be answered there and then or at the end of the recording. The goal of today's webinar is to give you all a brief introduction to the Kinetix and Teledyne Photometrics. For those of you who aren't familiar with us, the Photometrics brand has been designing and manufacturing high-end scientific cameras since the late 70s. Some major accomplishments that we've had are introducing the first scientific grade EMCCD, as well as the first back-illuminated scientific CMOS camera, both of which are still heavily used in microscopy today. We have an extensive relationship with Olympus and now Evident, with both custom cameras in the past and more recently our cameras being used as third-party products. On the screen right now you can see our current supported portfolio in CellSense, which covers a wide range of customer needs and imaging capabilities. With the newest addition on the right, the Kinetix, this is probably the biggest jump in performance that we've had. To put it simply, the Kinetix was our first attempt to make a product that removed as many bottlenecks as possible and provided the fewest compromises. How we did this was actually co-developing a sensor with the manufacturer. As you'll learn throughout the next segment, it really is a powerful and versatile camera that can do it all. What we're really excited about is the Kinetix being able to pair perfectly with the new IX85 from Evident and the imaging capabilities it's going to provide your customers over that large field of view. I'm going to hand it over here to one of the people behind the development of the Kinetix to tell you more.
Hello everyone, my name is Rachit Mohindra and I am a Senior Product Manager here at Teledyne Photometrics. And we're excited to talk to you today about our Kinetix sCMOS camera platform and its upcoming support in CellSense. Now that Evident has released the IX85 with its market-leading field of view, the Kinetix CMOS is the ideal camera to join the Evident portfolio. I will give you a brief introduction to the Kinetix camera, and then we will hear from some customers who have tested the camera with the IX85 to hear their feedback to see how well it performed. The Kinetix camera really emphasizes Teledyne's approach to product development, which is always a customer-led endeavor. We like to work with our users to ensure that we can provide them a high level of performance, especially while we're designing our cameras, while minimizing the amount of compromises that they have to face in their already challenging experiments. The Kinetix is a high-speed, high-sensitivity, high-resolution camera, and it provides this performance across a 29mm field of view. And this makes the Kinetix ideal for the IX85 platform, as it's the only camera that can pair up with the full field of view without compromising on speed or resolution. The Kinetix camera comes with 4 unique imaging modes, and each of these has been named to make clear to the customers what each mode was optimized for. And all 4 of these modes are supported in CellSense. The first mode is the dynamic range mode. This is the most used mode on the camera, and it's the go-to mode for everyday wide field or live cell imaging, where you can get a combination of the best dynamic range across a wide range of signals with a low noise floor and high full well, and that means it can enable imaging of both dim and bright signals within the same sample. The second mode is the sensitivity mode. This is the second most widely used mode on the Kinetix camera. This is optimized for when your samples have lower signal levels, such as thin slices, but it also maintains a relatively high speed. And this combination of low light performance with the high speed makes it great for spinning disk confocal microscopy. Thirdly, if your sample doesn't require speed, but you do need those high levels of sensitivity, then there's a third mode that calls itself subelectron mode. As the name implies, it provides the lowest noise floor of about 0.6 to 0.7 electrons. This gives you the sensitivity level that was previously only achievable with EMCCD cameras, for example, but now you're able to do it at larger areas and higher resolutions. And finally, the fourth mode, and maybe the most demanding mode, is the speed mode. And as the name implies, this mode is specifically for high-speed applications such as calcium imaging or particle tracking, or tracking particles in flow. At the full sensor array size of 10 megapixels, this mode runs at 500 frames per second. And for niche applications that require even faster frame rates or acquisition rates, like voltage imaging, we can run even faster with regions of interest. These modes running on the large field of view of the IX85, the Kinetix offers an amazing, complete solution for scientific customers no matter the application. But don't take our word for it, and hear firsthand from the customers who've tested the camera themselves.
Thank you, Ratchet. So we're now going to hear from two customers of both Evident and Photometrics, Dr. Urs Ziegler and Eliska Matsitskova, who run the Center for Microscopy and Image Analysis at the University of Zurich. They both have had hands-on experience with the Kinetix and the IX85 and provided some great feedback.
So my name is Eliska Matsitskova, and I'm currently working as a research associate at the Center of Microscopy and Image Analysis at the University of Zurich. And let's say my task as a research associate is at the facility support researchers in their imaging needs. We usually provide them on the trainings on the microscope, help them to troubleshoot if they need or optimize. And of course, we also have to, let's say, ensure that the microscopes are fully functional and, let's say, well maintained.
And my name is Urs Ziegler, so I'm head of the center. I'm being head of the center for the last 18 years. And in that role, I developed not only light microscopy here and expanded it to the various techniques which we use today. So we also do quite a bit in electron microscopy, from the classical transmission electron microscopy of plastic embedded samples to cryo-electron microscopy like single particle imaging or cryotomography. And the research area I'm basically most familiar with is neurobiology and immunology, because that's what I did in my previous research. And otherwise, we here support basically mostly life science. One example has been electron microscopy. As soon as we could image larger volumes or larger areas in an automatic fashion, things became for science much more interesting. The same in light microscopy. So with the light sheet microscope, the larger the field of view, the more volume you can capture and the more data you can capture. I think these are the two examples of the trends which really initially were a big limitation and still is a limitations due to the systems which may really have limited, well, optics normally have a limited field of view and they limit. And that's I think that's one of the bigger limitations we have.
I mean, would prove, of course, that the scientists would have like a faster acquisition, right? They would, let's say, spend less time on the microscope, and of course, they are also pressured, let's say, by some deadlines, and if they already, let's say, can acquire the data with large field of view, and for example, do less images in order to, for example, have stitched the task, or they can also, let's say, cover more cells which need to, let's say, include in the statistical analysis. Of course, that helps them, of course, a lot. But not only that, for example, also if you need to track like some object, and if you have a large field of view, you can track the object for a longer time before it moves out of the field of view. So let's say in this way, they could really help them to spend less time sitting in the microscope and fulfill some other task that they are pending, let's say, on the schedule.
I fully agree. The larger the field, the easier it becomes, first of all, to recognize something. Imaging across scales becomes also much easier. So the steps you need to acquire data sets across scales to have a high context imaging becomes easier. And if you have this classical field of views, you basically need a certain amount of time to acquire a single image to finally generate your data. And this limits severely an acquisition over a large volume, which you basically need to understand the function within tissue, organs, or within cells. Therefore, I really think there is one thing is the detector, which needs to have a large field of view. The other is, of course, the optical system you need to resolve. In microscopy, that also needs to support large field of views. And I think it can be nicely illustrated in electron microscopy again, where you have large field of view sensors, which allows finally then really new applications. I think cryo-electron microscopy or tomography, single particle, wouldn't have been as efficient as it is today without the large field sensors. And the same is in light sheet microscopy and in I would say in almost any type of light microscopy.
The large field of view provide, let's say, to our users like a huge benefit. So they can acquire really, let's say, fast or in, let's say, less time. And the other thing that we find very beneficial was also the high sensitivity. And that especially in the near infrared range, because recently we also have like a lot of demands, let's say, to excite in the near infrared range. And of course, we need a high, let's say, highly sensitive camera for that.
And with a relatively low noise. I think that's also important. In the past, you had quite sensitive cameras with a high noise, which makes imaging in the type of, like spatial biology. So you don't want to deal with a lot of denoising you may have to do. And spatial biology, well, which microscopy always is, the large field of view, you need to be fast. And therefore, if you want to be fast, you also need to be sensitive on one end and have a high signal to noise ratio, low noise. And I think that I find, well, so far tested, and I have to say in contrast to other cameras in the past, which have been sensitive, but the kinetics for routine applications, so far a lot tested in the lab, performs very well. Personally, I have to say I'm very happy with the performance.
Now we're going to hear from one of our longtime partners, Crest Optics. Luca Clario has been heavily involved in the marketing and training leading up to the launch of the SpinXL solution and has had many years' experience with the Kinetix camera.
So hello, my name is Luca Clario. I'm the marketing director at Crest Optics. In my role, I oversee product strategy and partnership, working closely with companies like Evident Scientific to bring advanced imaging solutions into the life science community. Crest Optics is an Italian company specialized in development of advanced optical system for fluorescence microscopy. We work for big industries of microscopy and also for pharma and academia and industry, and we propose OEM, ODM, and hybrid solutions. So we support research in neuroscience, cell biology, and high content screening, offering systems that combine speed, sensitivity and flexibility, and can be also integrated into complex workflows. So in our technology, advanced microscopy improving imaging quality, supporting confocal and super resolution. So we offer spin editing solution for light cell imaging market, so where you have the possibility to introduce fast confocal acquisition on large field of view for high content application. We have this X-Lite technology embedded in different solutions, from very compact and user-friendly devices, quite affordable. They can also be installed upright, and they are have their space into very sensitive labs where the space is not enough. And we have very high content screening technologies for big facilities. And this product is an example of this technology. And then we have a series of products that is based on lactic SIM technology for SIM super resolution. We help them to correctly address the market, posing the finding the correct messages for the new product that we collaborate with, and to define what's exactly the target, the market propositions, and the unique selling points of the technology. So our users often ask about high throughput capabilities, minimal phototoxicity, and a system that can be easily integrated into complex workflows. And we see a strong trend towards a larger field of view imaging and 3D acquisition at high speed and resolution. So the SpinXL helps overcome limitation like phototoxicity and for long acquisition times by using a fast, gentle spinning disk approach. Is a single disk mode coupled with multi-mode lasers, and is also enabling high throughput imaging via dual cam option and tailor disk geometry for spatial omics applications. X-Lite technology always allow the maximum field of view from the microscope body, and we try to reach the maximum in terms of speed and high content imaging that we can provide. So when paired with a large field of view microscope like the IX85 and a high resolution scientific CMOS camera, the SpinXL can image larger area faster and at higher resolution, supporting both large sample imaging and detailed structural analysis. There is definitely a trend for increasing the quality of the image in terms of how good is the illumination, how homogeneous is the field of view to obtain the best quality in terms of flatness of illumination. And the large field of view is always a trend and a big demand from the market. So if the confocal module and the cameras are able to support this feature, the multi-mode platform that can be generated is definitely interested for the market. With the Kinetix CMOS camera, we have really reached an impressive acquisition speed, excellent quantum efficiency across a broad range, and we significantly improved also the near-infrared sensitivity compared to the other technology or all the technologies. And these features are really valuable for our users that are working on live cell imaging and also fast multiplexed acquisitions. Yes, this is a definitely powerful combination because it's a ultimate balance between speed, optical, and spatial resolution. It's a very flexible and upgradable and multimodal imaging platform that is designed for live cell imaging, but it also can be used for high content and omics application, and it's very easy to train and transmit the knowledge to our end users. that this equipment in particular is expandable, so there is a possibility to upgrade the system in also after the first installation. So multiple disk geometries are also possible to be integrated, swap, and also additional cameras can be integrated into the system, so you can even play with the double kinetics simultaneously.
So there you have it. That concludes our guest section for the webinar. We have just a few more slides to go through and then we will address any questions. Firstly, we wanted to clarify that the full-size Kinetix will be available in CellSense. Although the chip size is slightly larger than what the AX85 can officially support, this can be adjusted in software with a region of interest. We supply a T-mount adapter in the box, which will result in the most secure and hassle-free mounting onto the IX85. We also will have support for the Kinetix 22. Now, as the name suggests, this is a cropped version of the camera that is adjusted for a 22mm field of view. This lower cost option is perfect for a dual deck IX85 where the field of view is restricted, or for older evidence systems. Although the field of view is smaller, there is no other change to the readout modes or other performance aspects, and all of the other features are the same. Both of the Kinetix models will be available from the end of April in CellSense 4.4. This is going to be one of the most extensive supports the camera has, as all imaging modes will be available upon release, as well as support for 2 cameras running simultaneously. You can even run 2 cameras over one PCIe card to make things a bit more simple. And speaking of cards, in addition to this, we now have evidence-specific part numbers to ensure you get the right mounting and cable configuration in each box. To help support the introduction of the Kinetix in CellSense, we have various resources available to help. We have sales documents such as guides to position against other cameras, which were available from your local sales rep, as well as more generic documents available on our website, such as our customer stories, which are always very popular when a customer is doing a specific imaging application, as they highlight why our cameras actually make a difference to their imaging. On top of this, our regional sales and support teams are always on hand to answer questions or provide demo equipment where needed. And if you're not sure who your local contact might be, we can provide it at the end of the recording. So, to summarize, the Kinetix and Kinetix 22 will be available in CellSense from the end of April. And based on the current demand, we are really excited to see what new imaging capabilities this will provide evident customers when paired with the IX85 and other systems. Thank you for your time and attention, and we hope you will find it useful. As mentioned, we'll now go through any questions that were unanswered in the chat.